So in this video, we're going to discuss the binomial distribution. So let's just jump right into the situation. So in a school of 30,000 students, one study found that 90% of the students were right-handed. So suppose you randomly selected 10 students from the school and you are interested in the number who are right-handed. So what we're going to do is first we're going to define the random variable x, and then we're going to make a PDF function, and then we're going to answer all these other questions based off of our PDF function. So the random variable x, so that's always answered in words, and so the random variable x equals the number of students who are right-handed, okay? So now let's talk about making the PDF function. So typically I have workbooks that you can practice in, but in this situation I think it's important that you know how to build this from scratch. So we have x and p of x. So our x's are going to correspond with the number of students who are right-handed in this case. And so we're talking about selecting 10 students. So what I'm going to do is I'm going to have a little table, and I can just go ahead and drag this down. So I have a little table from 0 to 10 of all the possibilities of students who are right-handed. Okay, so we are also dealing with a binomial distribution here because we have right-handed students and left-handed students, and we're considering right-handed students to be the successes, so to speak. So for the binomial distribution, so this actually has its own Excel function. So you can make a really good guess for this by just typing in binom, and you will see, so binomial distribution probability. So that's exactly what we want. So I am just going to note that here. So this is binom.dist, and okay, so that's the function that we want to use. Okay, so the other thing that I need to know is the probability of success. So my probability of success, i.e. the probability that you're right-handed, that's 0.9. Okay, so now let's go ahead and type in this function. So I've got binom.dist. So it's got the number s, the number of trials, the probability of s, and then cumulative. And cumulative in a distribution like this is always false. So the number s, that's what I'm trying to fill out in the table. And so I can't select the 0 right now because the formula is covering over it. So what I can do is I can just arrow over it, and now I can see it's like flashing a little bit right here, so I know I've selected the right thing. So that's the probability then of me choosing 0 students. And this is now asking for how many trials. So that's in another way we could say how many have we selected. And so I've selected 10 students, so that's going to be 0 out of 10. And then it's asking for what is the probability of our success, so that's s, so I can plug in a 0.9, and then remember this is always just going to be false. Okay, so now I have a function that is draggable. Everything else is going to remain the same. I just needed my choice of x to change. And so now I go ahead and I select everything. Now, I want to do a quick check to see if I have gotten this right. So I go ahead and I select everything, and I'll notice in the bottom right-hand corner, it says the sum of all of these is 1. So I feel like I probably created the right function here, and now I can answer all kinds of questions about this. So now I have just pasted all my questions just so I can remember them. So here's my PDF function. So when we're asked what is the probability that 6 or more students are right-handed, so for that one I can just calculate the sum. So here's 6 or more, and so there's a 99.8% chance that 6 or more students are right-handed. So does that make intuitive sense? It does, because there's a 90% chance that you're going to be right-handed. So it should feel like most of them are probably going to be right-handed, 6 or more. And then it says, so what is the probability that none of the students are right-handed? So that would be 0, right? And that's referring to this value here. So when you get values like this, if you're not sure what to do with this, one thing that you can do is you can ask Excel to round. So let's see, I'll change this to a number. Okay, so I came up here and I just selected, so it was previously in a different format. I wanted it to get rid of those e's, so just so that I feel more confident, I selected number here, and then I can mess with the amount of decimals that I have. And so now I can see here, right, so I can also format this. This still says 1e negative 10. I can just drop down here and go to number, and so now that will get me to a 0. But now I can see that, okay, yeah, there's basically no chance that if you select 10 students that none of them will be right-handed. That's very unlikely. And again, that makes total sense if the probability of everyone being right-handed is 90%. So that is not expected. So just knowing how to kind of interpret some of these values when Excel shows you something weird, that's a really important thing to be able to do. So the next question is, on average, how many students do you expect to be right-handed in this group? So that is now relying on you knowing what the formula for mu is. So the word average and expected, this is an expected value. Now, when we're talking about the binomial distribution, the one thing to remember is that for the average, this is a different formula. This is just going to be, what is this? This is going to be P times N. And again, that is because for an average, this isn't data that we have, this is probabilities. And so that is just a different formula that we have to use. Actually, I think the way that it's written in the book is NP. I'll write NP instead of PN. So anyways, to get my expected value, so I have 10 students total times 0.9. So I would expect at least 9 of them, which makes total intuitive sense that, yeah, 9 of them should be left-handed. And then it says, what is the standard deviation? So for the standard deviation, so again, that is its own formula. So this is going to be the square root of NPQ. So I can just type that into Excel. So my N is 10, my probability of success is 0.9, and then Q is your probability of failure. So you always take 1 minus P. So this will be 10 times 0.9 times 0.1. So my standard deviation in this case will be 0.948 and some change. Okay, and so that's what we've got for that one.